Guys, we have reached E Roman 1, and we have been asked to determine the number of moles of magnesium powder present in solid P1 magnesium. The relative atomic mass of magnesium is 24, as you can see, and the number of moles is equals to mass in grams over the relative atomic mass, of which that we found out that 1.2 grams from the initial equation there, 1.2 grams of magnesium powder was magnesium powder labeled P. It's the one that you are supposed to use the number of grams that were weighed, and then we divide it by the relative atomic mass, as you can see. When you do your divisions properly, you will just find that it is 0.05 moles as it has been written there. And then E Roman 2, we have been told to determine the number of moles of solution P3 that reacted with magnesium powder solid P4. So now in this case that we are supposed to write the equation first. As you can see that when you react hydrochloric acid plus magnesium, you get magnesium chloride plus the hydrogen gas. It's that effervescence that is produced during the reaction of magnesium powder and hydrochloric acid. It is the one that is we term as the hydrogen gas that is being produced in that reaction. That's why we have that equation as there. And the equation is properly balanced because that when you get the products, when you react the hydrochloric acid and the magnesium powder, you will get magnesium chloride and hydrogen gas. Therefore, the equation is supposed to balance because magnesium on the product side, it has a valency of 2, and chlorine has got a valence of 1. So now when you write the final equation, it's supposed to be magnesium chloride with a 2 there, as you can see. And therefore, the products and the reactant sides, the equation is supposed to be balanced on the reactant sides by 2, so that to get that equation balance. As you can see that on the other side, we have that 2 hydrogens on the reactant side, which is on this side. We have 2 hydrogens on this side, and the product sides we also have 2 hydrogens. And then the chlorines, we have 2 chlorines, and also on the reactant side and the product side also we have the 2 chlorines. So the equation is properly balanced, with the hydrochloric acid being aqueous and magnesium being a solid, and magnesium chloride is an aqueous and the hydrogen being a gas. So therefore we come to the 2 moles on the reactant sides produces the 1 mole on the product side. So now we equate it, X of hydrochloric acid, we take the cross multiplication of 2 times 0.05 moles over 1 there on the other side, 1 mole there. So it's giving us 1 mole. I hope that one has come to the end of that missing bit on the practical 7. Otherwise, thank you in advance, and remember to like, to subscribe, and also to share my channel. So the entire procedure is this one. The entire procedure, it is in Titration Practical 7. That is how it is. That's how it is. Let me just show you so that you can go through it for those ones who will be lagging behind. That is the procedure. It goes up to 7, and then on the other side, they are the questions that are supposed to be answered like that, like that, like that, like that, like that, like that. And then we have finished with this one. That is the summary of everything of Titration Practical 7. Thank you.